So welcome to Modern Healthspan, and thank you so much for joining us today.
Hi, Richard. Thank you so much for having me. I'm excited to chat with you today all about NAD.
Me too. Excited to talk to you. So could you provide a little bit of your background and how come you founded Nuchido?
Yeah, absolutely. So well, I'm a scientist. My sort of scientific training was very much in bioavailability. So how when we take drugs and nutrients and supplements or any molecules orally, how do they get through our gut and how do they actually get to our cells and enter our cells where they're performing their function. So that was what my PhD was actually in. And I then went on to have a career in drug development. So initially I was working in immunotherapies. And then one day I got moved on to a project that was looking at drugs to slow cellular aging. So this was like back in 2014. And back then it was, not many people were talking about longevity. So even I was like, wow, this is different. Like, what's this all about? So that is how I ended up getting involved in the aging space. And the company I worked for at the time were very interested in looking at different molecules and all the research that was coming out to show that if you could perhaps slow cellular aging a little bit, then you could maybe reduce the impact of multiple age-related chronic diseases in one go. So I was fortunate enough to have the opportunity to really get to understand and investigate all the different science and meet all the lead scientists in the field who were really pioneering in this research to look at whether we could take forward any development programs. So we did, and I led those, and there were two things that annoyed me a little bit about the world of drug development. The first was that I was going around seeing all these incredible breakthroughs in the academic labs that were life-changing, can completely rewrite the way that we deal with aging. But drug development takes a very, very long time. And I was like, there are things that people just don't know about that they could be doing now that are not going to be translated and get out to the general public for like 15, 20 years if we do the drug development route. The other thing was that a lot of molecules that we were investigating actually weren't your traditional drug molecules. They were natural compounds that were very well known, had good safety backgrounds, but because they weren't patentable by the drugs companies, they were not interested in them. So again, there was this question for me of, okay, there's molecules that work really, really well that are never going to become drugs and that are never going to get the research that they deserve, yet people could be using some of these now to try and improve their health span. So I left that world in 2017 and I decided to found Nuchido, where my mission with the company was, how can we take all this cool science that's happening in the world of longevity, take my background and expertise from how to develop molecules that actually get absorbed and produce an effect in the body, but go down the route of dietary supplements, because this is a way we can get that science out to people quicker. So yeah, that's how I got into it. And I think a lot of people thought I was crazy leaving my very credible job in drug development to start a supplement company. And there were a lot of raised eyebrows. But your body has no idea what is a supplement, what is a drug, what is a nutrient. They all have equally powerful effects. And my mission is, how do we bring some credibility to the world of supplements, especially in the space of longevity?
Right, that's really interesting. So I know, so Dr. Brian Kennedy, so one of the things he said is, that's the message that, if you can slow down aging, then it may impact many different diseases of aging. But he's been trying to sell that and nobody's listening. So it's interesting that even though your company was looking at it from maybe from the commercial point of view, but they were actually thinking about that, like trying to slow aging.
Yeah, so I'd say the reason that a lot of the big drugs companies don't listen is simply because it's very hard to test and prove that something is affecting aging. For any clinical trial for a drug, it has to have, an endpoint of a disease, and aging is not classified as a disease yet. and therefore it's very difficult to pitch that idea. I know a lot of companies are going around it in a bit of a different way, where they you know, some of the trials that are doing are looking at delaying the onset of some age-related diseases, or looking at specific diseases that are known to be, you know, have a biggest risk factor of your age, and seeing if they can be used as the primary endpoint or indication for a trial. But I think certainly over the time that I've been involved in this field, there's been a huge shift. You know, back when I got into it, it was a very underground, like crazy thing that some scientists thought was good. And now it's becoming much more mainstream. People are really recognizing that the potential. And you know, at the end of the day, it's for everyone, not just drug development companies. It's a completely different mindset change of how we are approaching medicine. Especially when it comes to aging. So I think it's not surprising that there's resistance, you know, but as they always say, everything's always a crazy idea until it becomes obvious. So
yeah, yes. Okay, so you quit your company and you started Nuchido, and Nuchido has a product called Time Plus. So before we kind of dive into exactly what Time Plus is, could we talk about, you know, what is the problem it's trying to solve? So how is it, you know, which part of aging are you looking at, and how are you trying to solve that?
Yeah, well, when I was doing all of the research into longevity, you know, my major mission was to look at all the different targets. Like, as a company, what could we target that seemed to have good science behind it that would slow cellular aging? And as anyone in the field of longevity knows, there are multiple hallmarks of aging. So these are the 12 root causes of cellular aging, the things that go wrong at the cellular level to cause everything that we experience as the aging process. And there are lots of different interventions that were being studied as ways to try and improve the hallmarks of aging. And one that kept coming up again and again was NAD. And this was, you know, was a really intense area of study. This molecule that we seem to have in our cells, it's important for hundreds of different reactions, but most importantly for energy production and also repair. And unfortunately, it seems to decline in a lot of our cells as we get older. And this decline seems to firstly turn down energy production, and secondly, turn down a lot of cellular pathways that are important for cellular health. So important for keeping our cells in good condition, making sure everything is repaired. And that gets turned down, resulting in an accumulation of damage and, you know, cellular aging. And the thing that really stood out to me for NAD was it was found that if you could boost it, that it seemed to have a huge impact across all the different hallmarks of aging. But the most astounding thing was that it was actually pretty simple to boost. This was something that could be done with a dietary supplement. And a lot of the studies were demonstrating that by using dietary supplements, you could increase NAD levels, and it was having beneficial effects. As opposed to some of the other more complicated ways of trying to interfere with the aging process that involve, you know, removing cells or trying to genetically manipulate cells, which, you know, maybe is the future, but right now are a bit tricky. So that's what really drew me to NAD. But what I could see was that a lot of the products that were out there, a lot of the ways that this science was being translated didn't quite match up with what all the latest science was showing, in the sort of sense that a lot of the products out there that were designed to boost NAD weren't actually fixing the causes that were causing NAD to go down in the first place. They were kind of ignoring it.
Right. Yes. And yeah, so I mean, certainly in preclinical, like boosting NAD seems to work, but the dosage is very high. Yeah, generally speaking. So how does Nuchido address it kind of in a different way? Can you talk about the strategy that you use?
Yeah, so our strategy is basically fixing the root causes of cellular NAD decline. So we know that there are a couple of reasons why NAD declines as we get older. The first reason is that there is an enzyme pathway in our cells called the salvage pathway. And this is the primary pathway that makes and recycles all our NAD. When we are young, when our cells are in good health, this is where all our NAD comes from. Basically, precursors are made into NAD. So precursors are like the building blocks for NAD, and the precursor that the cell uses is one called nicotinamide, which is a derivative of vitamin B3. And when NAD is used up through multiple cellular functions, whether that be through activating the sirtuin, longevity genes, or through different DNA repair enzymes, for example, that use NAD as a fuel, this big NAD molecule is actually broken down, and it's broken back down into the nicotinamide precursor. Now, in young healthy cells, this salvage pathway literally scoops up the nicotinamide and it recycles it straight back into fresh NAD again, which is great because it's a very clever pathway. That means that as our use of NAD goes up, then production also goes up to replenish it. And equally, if NAD use goes down, there's less precursor, so NAD production goes down. So it's a very neat way that the cell has of finally controlling our NAD levels. But what's been found is that a key enzyme, what we would call a rate-limiting enzyme, in this pathway called NAMPT, actually declines as you get older. And this can be seen across cells in not only humans, but multiple different species. And this means that as NAD is being used, actually it can't be efficiently recycled back into fresh NAD again. So we start to see NAD levels decline. And when I say it's a rate limiting enzyme, it means that within this pathway, the amount of NAD that is produced is directly dependent on the availability and the activity of this enzyme. So when it starts to decline, that is a problem. Now, that's one of the issues. The second major issue is that as we are getting older, our cells are actually using up more NAD. And this is firstly just because they've been around longer. They've got more damage. They have more DNA damage, which NAD is required to fix. They have a lot more inflammation as we get older. We have chronic low-grade inflammation. And we know the inflammation especially is a particular problem because what you tend to see is that in cells that are a bit more inflamed, they have a higher expression of an enzyme called CD38, which is an enzyme that drives a lot of inflammatory processes, but it is a major NAD consumer because for it to work, it actually needs NAD to fuel it. So this kind of creates the perfect storm where not only is your NAD production gone down, but also it's right at the same time when you actually need more NAD to actually fuel all of this repair, and it's being wasted by these inflammatory processes. So you see an exponential decline as you age. So what Nuchido set out to do with our product is basically, can we actually fix these issues? Because a lot of products are simply supplying, or a lot of dietary supplements are simply supplying the raw material to make NAD, but completely ignoring the reasons why NAD is going down. So things like NM, NR, they are not fixing those pathways. So our strategy is very different in that it's not just putting a precursor in there to give the body more of the raw material, it's actually looking at why the NAD is going down and fixing those issues. And I often get people to sort of think of the analogy of the cell being a factory. So if you had an NAD producing factory and you went into the factory because production had gone down and you saw that all the machines were broken, the pipes were leaking, and it was a bit of a mess, you certainly wouldn't say, well, just order more raw material and obviously more NAD will come out the end. You would go, no, we need to fix the issues. We need to fix the machines. We need to fix the factory. And that was exactly the view I had of our product. It's not just ignoring those issues to increase NAD production. It's actually fixing the issues that are underlying it.
Right. And so, yeah, so NAMPT, this rate limiting enzyme, it is maybe the key or one of the key elements here because it, yeah, as you say, it goes down with age. So how are you activating NAMPT? Because yeah, I mean, I spoke with Joe Bauer, Dr. Joseph Bauer. He kind of said that, well, it's difficult to actually activate NAMPT. So how do you do that?
So there's a couple of different ways. So what we know is that one of the best ways, so aside from molecules and and products, one of the best ways to activate NAMPT is actually exercise. So it's been demonstrated in humans that if you put humans on exercise programs, their NAD will go up. And the reason that the NAD goes up is it's because you naturally increase your NAMPT levels. Now, at a sort of cellular level, what's actually going on here is we see that exercise is inducing an energy stress, and that is detected by something called AMPK in the cell. So AMPK is like the chief energy sensor. It detects if there's an energy stress, and it activates pathways in the cell that will basically make sure that your cell can survive that period of energy stress. And one of the things that AMPK directly goes on to activate is NAMPT. So one of the strategies that we use is a molecule called alpha lipoic acid, which is something that is known to activate AMPK, with the hope that once we've activated AMPK, that it would then go on to activate the same cellular pathways in the body that are switching on NAMPT. We also use rutin, which contains quercetin. Again, quercetin is a molecule that seems to be more of a direct activator of NAMPT. So those are the two strategies that we use to try and boost levels of this enzyme. And we have done a clinical study to prove that we do actually increase levels of the enzyme. So we're fairly confident that actually this strategy that we're using, those two ingredients in our product, are doing exactly as we intended to do, to switch back on the NAMPT enzyme. And that trial is currently in peer review at the moment. So we're hoping it will be the first published human study to demonstrate that you can increase levels of this enzyme in humans.
Excellent. And yeah, I would definitely like to dive into the trial a little bit later. Okay, and you said, so you use rutin rather than quercetin because rutin is more bioavailable. I know quercetin is definitely not.
Yeah, quercetin's not good. So again, back to me being a bit of a stickler about ingredients because of my background in bioavailability. So rutin is a quercetin glycoside. So it's basically like rutin, but with a little sugar attached to it. And what that seems to do is protect it through its oral transit and gut transit, and seems to increase its bioavailability and absorption. Sometimes, people will see in vitro studies which are using pure active molecules, so things like quercetin, and they'll say, oh, quercetin does this in cells. But just because quercetin does something in cells doesn't mean that you can give quercetin orally and it's going to actually get through the gut and get into the cells and do the exact same thing it did when scientists put it in a petri dish. And this is one of the issues with a lot of supplements in the longevity space, in that people are trying to take the pure active molecules when actually they would never exist like that in nature. So it's very hard for our bodies to absorb it. So for us, we use a lot of the more, how shall we put it, more of the natural forms of these active ingredients, because they are better absorbed and it's also slightly more protected going through the gut.
Right. And the other thing is, I mean, we know that activating AMPK is positive. And actually, I knew that exercise produces more NAD, but I didn't kind of know that those two were related. So the way that exercise creates the NAD is through activating AMPK, which then activates NAMPT.
Yeah,
Right?
Absolutely. So there were studies that were showing with resistance training. I can't remember how many weeks. I think this was 9 or 10 weeks. That in these individuals, they showed that if they increased NAMPT levels by about, I think it was 15%, and that equated to about 120% increase in NAD levels. So yeah, and this is exactly the role of NAD. You know, everyone talks about NAD as this buzz molecule, but a lot of people don't really understand its purpose in our body, which is basically a sensor. It acts as like an interface between what is going on in our outside world and how the cells should respond in terms of energy stress. So anything that creates energy stress, so fasting, exercise, where our energy is either being depleted or it's not coming in, will activate AMPK, which will then switch on NAMPT to boost NAD. So when you're fasting, you're exercising, NAD actually goes up. And that is basically telling the cell, we have a situation of energy stress. We need to make sure we've got enough NAD for our mitochondria to continue producing energy. And we also need to make sure we've got enough NAD to fuel all of the repair processes that we need to make sure our cells are kept in good health during this period of stress. Equally, on the flip side, when we're not exercising, there's no energy stress. So modern humans, essentially, we're sitting all day, we're eating all day. Our body's like, there's no stress. Like, just why do we need to switch on these repair pathways? So, AMPK is not getting stimulated. NAMPT is not getting switched on like it should be. NAD's, just staying fairly flat and low because it doesn't need to go up and signal to the cell to start, looking after itself. So actually a lot of the sort of practices that seem to be beneficial for longevity are, not the whole mechanism of action, but a big chunk of that mechanism of action is actually coming via NAD.
Interesting. Yes. So we are taking NAD and we're creating NAM, nicotinamide, in large quantities, right? And so there was a couple of things. So one is, if you have too much nicotinamide, is that going to inhibit like sirtuin 1 or sirtuins? Because the sirtuins are going to try and create more nicotinamide, and if you get too much of a buildup, it may have a kind of negative impact. So do you think that happens? So
our cells do not like things building up, especially not nicotinamide. Anything in the cells where the cell is under a control of homeostasis, it tries to keep things constant. And what we see is that as NAD is used, it is broken down into nicotinamide, and in healthy young cells, that nicotinamide is dealt with before it even has a chance to build up, because NAMPT uses it up and creates fresh NAD again. So in a usual healthy state, we wouldn't expect nicotinamide to build up. What we tend to see in older cells is that as NAMPT gets turned down and it's not working as efficiently, and also as more NAD is being used, we do start to see that there's more nicotinamide. But this never reaches levels that are going to start to impact cellular functions in a negative way, because what happens is our cells respond by changing something else. And what they do is they increase expression of another enzyme called NAMPT, which is a nicotinamide methylating enzyme. So again, you can see in older cells that have this dysfunction, that expression of this NAMPT actually goes up. And what this does is it attaches a methyl group to nicotinamide and signals its excretion out of the cell. So this is, again, a way that our bodies make sure that we don't start getting excess levels of nicotinamide in the cells that may inhibit other things. Now, there are a lot of people that would argue that nicotinamide inhibits sirtuins. For me, I have not seen any convincing evidence that this actually happens in normal physiological states. Every single paper that people rely on as evidence for this is done in vitro, in a petri dish, in cells, at very high concentrations that would be very unlikely to reach in physiologically in cellular conditions, because our cells normally as a whole system do not let things build up like that. So yeah, it's important to not look at isolated pathways and assume that something would happen. It's important to look at biology as a whole, because everything is interlinked. And this has been demonstrated really nicely in some of the the studies on NR. So with NR, what you see is that in the human, this is human clinical studies, you see that as NR dose increases, NAD does increase to a certain level, but then it plateaus. Okay, so it's not like you can keep giving more and more and more NR. This is the precursor for NAD, and it will equal more and more NAD. It gets to a point where it just stops, and what you see is a huge increase that just does keep going up and up and up of the excretion of methyl nicotinamide. So what that shows us is that in these volunteers, that as their cells are reaching a capacity where their salvage pathway just simply can't keep up with the amount of NAD that's being created by NR, broken down and used, converted into nicotinamide, and then not recycled. And their bodies are having to try and deal with this by actually excreting it as methyl nicotinamide. And this is why you'll often hear people say that are taking NR and NMN that you need to make sure you're taking methyl donors, because then this can cause other issues with methylation, because all those methyl groups that this NAMPT enzyme is using to stick onto nicotinamide and get rid of it should not be getting used for that. They should be getting used for much more important things like DNA repair and epigenetics.
What is the impact of having low methyl groups? Is there any kind of clinical symptoms?
The impacts are huge and the symptoms are very varied, and that is because methyl groups are so important in many different cellular processes. So the most important, well, two things that I have just mentioned are DNA repair. Methyl groups are very important in that, and also epigenetics. You can see that, you know, a lack of methyl groups means that the methylation processes that are tagging our genes to switch them on and off are not available to do that. So, I mean, clinical manifestation of symptoms can be very diverse, and this is where people often have issues that they really don't understand what the root cause is. But, you know, tiredness, fatigue, all sorts of different things, you know, inability to recover from things, getting sick all the time, just generally, because if your cells do not have the methyl groups they need, it causes a general decline in cellular health and cellular function, right across the board, affecting a lot of different, you know, bodily functions.